a special kind of triangle, the isosceles triangle, which gives us some extra special theorems that we can use to help us solve problems. So first, we're just going to talk about some vocabulary with our isosceles triangle. First of all, you know that these little markings here, oopsies, these markings here and here mean that those two sides are congruent because isosceles triangles have two congruent sides. And so we call those congruent sides the legs. So that's one leg, and then this is the other leg. And the other side we call the base. Okay, so angle-wise, the angle up here at the top, this is called the vertex angle. So where the two legs meet is the vertex angle. And then the other two angles, angles A and C, those are the base angles. Okay, so nothing super fancy so far. So let's look at, though, what the base angle theorem says. So the base angle theorem says, if two sides of a triangle are congruent, aka in an isosceles triangle, then the angles opposite them are congruent. So essentially what that says is, I'll draw you a picture over here. It says if we have an isosceles triangle and that these two sides are congruent, then these base angles are also congruent. So that's what the base angle theorem says. That sides congruent show us where congruent angles are. The base angle converse just goes the opposite direction. So the converse says if we start with a triangle that has two congruent base angles, then that means those sides across from them are also congruent. So it can go both ways. So base angle theorem is sides to angles, and then the base angle converse is angles to sides. So let's look at some examples for how we could use these things. All right, so in example number 1, we have that these two triangles are connected, and for just the left triangle, we want to solve for the base angle B. And so since these two sides are congruent, that means that the angles across from them are also congruent. So I'm going to mark these congruent. And according to our triangle sum theorem, we know that angles in a triangle always add up to 180. So for this triangle on the left, how many degrees are left over after we subtract 60? 120. So if these two angles have to equally share 120, each of them are 60. So that makes B 60 degrees. All right. Okay, so then for the triangle on the right, we're solving for the vertex angle A. And again, we had marked that these two sides were congruent. So if the left side and the bottom side of that triangle are congruent, that means that these angles are also congruent. So if one of them is 30, that means the other one is 30. Which means we have used 60 total degrees in that triangle, which means how many are left over for A? 120. Amazing. Okay, let's try another one. So example 2 says solve for the value of x and then the length of RQ. Okay, so if we're solving for x first, we have to figure out how those two sides are related, where the x's are. But we can do that because these base angles are marked congruent, which means that the sides across from them are also congruent by the base angle converse theorem. So I can mark those two sides congruent. And if the sides are congruent, we can set them equal to each other. So x squared minus 8x equals 3x minus 10. Okay, and so remember, if you see an x squared and regular x's in your equation, what will you have to do? Factor factor. So before we factor, let's move everything over to the left side so we have an equal 0. So I'm going to subtract 3x and add 10 to both sides. So I get 8x squared minus 11x plus 10 equals 0. And I will give you guys a second to practice factoring, and then we'll check it together. All right, so to factor, we were looking for two things that would add to negative 11 and multiply to positive 10. So that would be negative 10 and negative 1. So once I finished my box method, my factors were x minus 10 and x minus 1, which means x equals 10 and x equals 1. But we got two solutions, so what should we probably do? Plug them in, check for reasonableness, because we have some sides, and we know that side lengths cannot be negative. So we need to make sure that neither of these x's will give us negative values. So if I plug in 10 for x over here, I'll get 100 minus 80, which is positive, so that's good. And over here, I'll get 30 minus 10, which is positive, so that's good. If I plug in x equals 1 on the left side, though, I'll get 1 squared is 1 minus 8, which is negative 7. That's not good, right? Because no negative lengths. So that means x equals 1 is not a good solution. So x equals 10 is our only solution, and now we will find the length of RQ by plugging it in. So RQ equals 3 times 10 minus 10. So RQ equals 20.